2011 Projectiles, question 3b. A plane is inclined at an angle alpha to the horizontal. A particle is projected down the plane with an initial speed of 10 meters per second at an angle 45 degrees to the inclined plane. The plane of projection is vertical and contains the line of greatest slope, which is what we're always told in these questions. The particle strikes the plane of Q with an landing angle theta, where tan of theta is 1 over 4. Find the value of alpha, and if the magnitude of the rebound velocity of Q is 5 root 33, find the value of E, the coefficient of restitution, and you are given the following diagram. So this is alpha in here, theta in here, and we have the tan of alpha is 1 over 4. Sorry, tan of theta is 1 over 4. Okay, we start by looking at our accelerations. We've got G going down this way. Now, in this question with the downward slope, we've got my alpha in here, the J direction, and the I. We have a positive G sine alpha for X, it's going down, and for J, we have minus G cos alpha. So the range of J at the strike at Q is equal to 0, or the distance traveled in the J direction. Maybe the range of J could be another way to say it there. But so if we say 0 is equal to ut plus a half at squared, we have information to fill into this. My initial velocity vector is traveling at a speed of 10 at an angle 45. So we set that up. 10 cos 45 times I plus 10 sine 45 times J. So my initial velocity in the J direction, this u, is 10 sine 45. So we can work out the time it takes to get there. 10 sine 45 times t minus my acceleration. We said it was plus for x and this minus for y or j. So we're looking at minus g cos alpha over 2. And we're looking for alpha, so this is where the alpha will come in. Minus g cos alpha over 2 times t squared is going to be equal to 0. So we simplify down for t. We're going to get t times 10 by sine 45, so 10 over root 2, minus g cos alpha by t over 2 equals 0. So my initial time equals 0, and 10 over root 2 have to be equal to g cos alpha times t over 2. So 20 over g cos alpha, root 2 g cos alpha is equal to my time. 20 over root 2 is 10 root 2, so time is equal to 10 root 2 over g cos alpha. So we're given the tan of the landing angle here, and we know that the landing angle is minus the velocity of j over the velocity of I. So if we bring that into this question here, let's get the velocity of I and j. We have the time, so let's get the velocity of I. Velocity of I at this point is the time it takes to get there, and we're using v is equal to u plus at. So the u for I was 10 cos 45, and the acceleration for I is g sine alpha, so plus g sine alpha times time, which is 10 root 2 over g cos alpha. So we can see a tan coming in here. We're going to get 10 cos 45, which is 10 over root 2, and 10 divided by root 2 is 5 root 2. So 5 root 2 plus, you can see here, sine and cos is going to give me tan. The g's cancel, so we're left with 10 root 2 tan alpha. 5 root 2 plus 10 root 2 tan alpha. That's my velocity in the I direction. So we have a value for this, it's equal to 1 over 4. So let's get the velocity of j. We should be able to simplify it down then. Velocity of j, u plus at. So it was 10 sine 45 for my u. My a, just double check it here, was minus g cos alpha. Minus g cos alpha. And my time, again, was 10 root 2 over g cos alpha. So let's see what happens here with the g cos alphas. So we're going to get 10 over root 2, which again is 5 root 2, minus 10 root 2 is going to give me altogether minus 5 root 2. So if we put these into this fraction, we're going to get a minus 5 root 2. So I'll just write here 1 over 4 is equal to 5 root 2 over 5 root 2 plus 10 root 2 tan alpha, which is my velocity of j, or minus my velocity of j, or velocity of I, at the landing point, which was theta, and we were told that the tan of theta was 1 over 4. So 20 root 2 is equal to 5 root 2 plus 10 root 2 tan alpha. Simplifying down, we're going to get 15 root 2, bringing this guy over, and we're going to have to divide by this guy to get tan alpha. That's 10 root 2. That's going to be my tan alpha. So tan alpha is equal to 3 over 2. So that's going to give me a value of 56.309. So 50 alpha will be 56.30931 degrees. Part 2 of this question. We're looking for the coefficient of restitution. When they asked this, I think in 2012, we were given the coefficient of restitution. Here we have to work it out. So we're told the magnitude of the rebound velocity at q, so the magnitude is 5 root 33. So let's figure out what's going on here. The magnitude is 5 root 33, and we know the magnitude is going to be the square root of the velocity of I squared put the velocity of j squared. So we go and get the velocity of I and the velocity of j. So the velocity of I was 5 root 2 plus, and the tan of alpha was 1.5, so that's going to give me 10 by 1.5, 15 root 2, so that's 20 root 2, and then we get the velocity of j to be minus 5 root 2. So if we square these two things, we're going to have to multiply this by minus e, so we're going to have a positive 5 root 2e, so that's my 5 root 2e. That, just let me rub that out, the e's outside the square root, 5 root 2e plus 20 root 2, all to be squared, is going to give me an answer of 5 root 33. So we multiply this out, we're going to get the square root of 400 by 2, that's 800, plus, I left out the square there, 25 by 2, which is 50, and that's going to be equal to 25 by 33. Well, 25 by 32 is 800, so that's 825. So if that was this squared. I'm just skipping a stage here, so that would actually eliminate this square root. Jumping ahead of myself. So I should technically put a bracket around there. So we're going to get 800 plus 50e squared is equal to 825. Just write that again. 800 plus 50e squared is 825. So 50e squared is 25. E squared is 25 over 50. So e is going to be the square root of 1 over the square root of 2, which is 1 over root 2.